My research involves chemical modulation of DNA repair. DNA is not an inert molecule, it's constantly damaged by endogenous or exogenous damage sources, and thus we need a repair system. And this repair system is very complex, different pathways which are interconnected and are regulated during cell cycles with post-translational modifications. Yet all these reactions are very basic chemical reactions. In fact, they are so basic that they can be understood with high school chemistry. We developed a molecule that abstracts a proton and induces an elimination in the DNA backbone. And it does that so in the biochemical cascade of an enzyme. And during this cascade, that means that the reaction is sped up and repair is increased. And this allows us to control the starting material as well as the product of the reaction. And the applications of that are, for example, increased oxidative DNA damage repair for neurodegenerative diseases, inflammation or obesity, even aging, and as well a reprogramming for the treatment of cancer where we can shape new synthetic lethality.
What motivates me in my research at the core is, I guess, this inclination to understand the fundamentals of life. It still astonishes me that we can peer into the inner workings of the world and tease apart even how our own cells work. And the fact that I can do this each and every day with a team of other like-minded people is really the dream job for me. And I also very much enjoy and am motivated by the inherently collaborative nature of science and how each discovery builds upon the last and each finding builds on our collective knowledge.
So what motivates me in my research is to venture into unexplored grounds in the field of mechanobiology and discover how forces, physical and mechanical ones, affect cellular behavior. What's really exciting about this research is its multidisciplinarity, the collaborative potential, but also its impact on diverse research fields. Indeed, this research can not only change how we view certain matters in our evolutionary past and present pathologies, but also can better prepare us for future space endeavors where we anticipate changes in cellular mechanobiology.
I submitted an application to the award because of all the feedback that I got from the scientific community. When we published the original breakthrough manuscript in summer 2022, a lot of researchers reached out via email or even called and wanted to talk about their research. Of course, we started a lot of collaborations, and some of them we already have foreseen earlier. So we were working on neurodegenerative diseases, for example, and inflammation. But other researchers reached out and saw a potential in their research where boosting of oxidative DNA damage repair could have a really big impact. And we have not foreseen that, and that was very, very rewarding. And I wanted to basically expand on this dissemination strategy and let the scientific community know. I hope that the Eppendorf Award will help me with the visibility of my research. When we are communicating our science, we often have very little time to communicate during lectures or during symposia. With the media attention of the Eppendorf Award, I hopefully can start a discussion much deeper and more advanced. Secondly, I'm currently trying to expand on the technology base. And the technology base requires some third-party funding for starting my own group. So I hope that the Eppendorf Award will help there. Thirdly, it also helped me to revisit my communication skills when I was talking to my family, to scientific experts, but also to media, to interviewers, to journalists about my prize-winning research.
I became a biochemist because of proteins. I've always been fascinated by tiny things, and proteins are some of the most important tiny things, in my opinion. These biomolecules fascinate me because they perform such diverse functions, from enzymatic activity to architectural scaffolds, and even gene regulation. In essence, proteins are the movers and shakers of the cell. And as with objects that we use in our daily lives, design or form largely determines their function. And in this way, proteins are similar, where their form or structure largely determines their function. And I think this is what drew me to this aspect of biology, where similar creative processes are ways of thinking applied in art and design are also applied to visualization of protein structures, generating hypotheses to reach an understanding of the art of life.
So I became a scientist due to an innate drive of curiosity and, I guess, creativity that I was continuously nurtured throughout the years by amazing human beings around me, most of which were women, but which include early on my mother, and later on, more recently, my doctoral and postdoctoral advisors. Now, more specifically, I became a cell biologist because I think that studying cells may provide us key answers to critical questions that I find interesting, such as where do we come from, what are we made of, and where are we going?
In the future, we want to expand conceptually as well as in the translational medicine sense. Right now, we have used a small molecule to do a very specific reaction in an enzyme. The question for the future is, can we develop other small molecules to do other kind of reactions? So we need to source the proteome, the DNA repair pathways to find these new reactions. But maybe this also exists outside of medicine. So I'm thinking about sustainable synthesis as well in the energy sector, basically decreasing polymerization state of carbohydrates, generating biofuels, for example. This can also be done without small molecules, so we are thinking of doing biocatalysis research, looking into protein engineering and mutation to generate hyperactive mutants and use them for these purposes. What excites me the most for the future is the interaction with clinicians and other translational scientists. At the moment, we are already collaborating with researchers focusing on inflammation, cardiac fibrosis, but also boosting CAR T-cell therapies. And that's something that's very close to my heart.